On behalf of everyone at JPS, we appreciate your joining us today. I am Carol Hollingsworth. I'm the JPS Vice President of Sales. Providing you with today's presentation is the JPS Senior Sales Engineer, Iggy Brigado. Today's presentation is on the CPM-3, the SNV-12 Receiver Voter Control Processor Module. Iggy will discuss and demonstrate some of his tips of the trade. These will include some CPM-3 features that can be implemented to assist with troubleshooting. JPS is very proud of his industry-leading SNV-12 signal and noise voter comparator. It is the most flexible, conventional voter on the market today. It has been field proven since 1998. It is built and supported in the USA by JPS Interoperability Solutions. JPS was the first to develop a DSP conventional voter. The SNV-12 Voter is the most flexible voter on the market. You can ask, why buy the JPS SNV-12 Voter? It's the quality, the experience, the flexibility, the features, and the benefits of the SNV-12 Voter. Now with IP backhaul, and it's all backed by JPS engineering and JPS customer support. Now let's get to the real reason you're here today. Allow me to introduce Iggy Brigado. Iggy.
Okay, Carol, again, thank you, appreciate that. And I'd like to welcome everybody to the JPS Interoperability Solutions Weekly Products Briefing Webcast. I'm Iggy Brigado, Senior Sales Engineer, and as you know, we also have here with us Carol Hollingsworth, our Vice President of Sales. And in this week's webcast, we're going to discuss the CPM-3 Control Processor Module used with the JPS SNV-12 analog receiver voters. And this is the latest version of the voter's control processor module, which superseded the CPM-1 over 10 years ago. And hopefully this webcast will enlighten those of the supervisory and control functions of the CPM-3. And whether you're considering upgrading your existing SNV-12 voters with more advanced control processor modules, or you currently have CPM-3 modules and are unaware of the supervisory and control features, our goal today is to enlighten. And as usual, I like to set the foundation. And for those of you that may have not had any experiences with the SNV-12 analog receiver voter, let's just have a non-technical description of the SNV-12 voter. And to increase the coverage area of a radio system, often multiple fixed receiver sites are strategically deployed throughout a region to provide the ability for a roaming subscriber unit to seamlessly hand off their transmissions from one receiver site to another receiver site. And so the voter or comparator is used to gather the received audio from the multiple fixed receiver sites and then select audio from one and only one site that exhibits the best audio quality, and then delivers that audio to the repeating transmitter or to even the dispatch console. The receive audio from each fixed site is assessed based upon spectral noise above 2.2 kilohertz, and that would be for FM conventional communications. And for true signal and noise, we use that for AM or HF communications. But I do want to also briefly talk about some of the supporting modules that populate the SNV-12 voter chassis, as we'll see later. The control processor module can really influence these modules. And so the CIM-2A module is the console interface module that directly supports the console, as its name implies. Interestingly enough, all audio, whether it's voted receive audio or audio from the dispatcher, must pass through the console interface module. So in terms of interfacing and in terms of audio, this is really a very important module, and we even regenerate transmitter keying tones within the CIM-2A module. The SVM site voter modules, as their name suggests, supports the remote receiver and transmitter sites. They contain digital signal processors that are used to assess the quality of the received audio, and the audio quality information that they capture from the remote receiver is then shared with the control processor module to allow the assessment and selection of a single high audio quality receiver site. And specifically, the SVM2 site voter module primarily supports analog backhaul links between the single receiver and the voter. And those links can include lease line, copper radio tie lines, T1 microwave, and RF radio links. The SVM3, the two modules at the right of the chassis, are paired with three QMT modules that work in concert and serve similar purposes to the analog SVM2 module, except the SVM3 will support the backhauling of receiver audio over digital links. And you can populate the 12 available slots in any combination of SVM2 and SVM3 modules. And so this is a hybrid solution. And you can even stack three chassis together to support up to 36 all analog backhaul sites or up to 60 sites with a blend of SVM2s and SVM3 modules. So the backhaul architecture can be exclusively analog or exclusively IP or a hybrid architecture of both analog and digital backhaul links, all supported without GPS or timing references. You can check out some of our last product briefing webcasts where we did describe the SNV-12 IP backhaul solution. And finally, the CPM-3 Control Processor Module is the primary processor of the chassis, and it has lots of responsibilities. For instance, assessing the receive audio quality measured at each of the SVM2 modules, and then selecting a single receiver site. We call that the voting criteria, which results in the repeating of the best quality audio or delivering that audio to the dispatcher. All right, so let's talk specifically about the CPM-3 module. And as I mentioned earlier, there are lots of longtime end users that probably are not aware or do not realize the ability to remotely interact with the voter. In fact, one can set up a CPM-3 control processor module as well as the entire SNV-12 voter chassis from simply the dip switches and rotary switches and jumpers on all of the modules without even ever logging into the CPM-3 module. But for remote supervisory and control capabilities, you'll find that the CPM-3 really has a lot to offer. I'd like to first make a comparison with the older CPM-1 control processor module, which was superseded by the CPM-3 several years ago. And the most obvious difference is the Ethernet interface and the link LED, which I'll talk about here in a moment. But at a high level, both modules perform the same functions, but there are some operations that the CPM-1 cannot support, such as additional audio delay functions at the audio bus, and also the increased number of receive groups for those of you that are interested in transmitter steering. But for the most part, the addition of the web browser user interface to facilitate control and supervisory activities is really by far one of the most important improvements in terms of the CPM-3. And because of the network, we can perform these activities remotely. In terms of remote control or monitoring of the voter, a computer with a serial interface was required if the SNV-12 was equipped with the older CPM-1 module. And as you know, there is a DB9 connector at the rear of the chassis. In the case of control and monitoring, one would have to use a terminal emulator as the user interface. Without being said, the CPM-3's ability to access supervisory and control functions of the voter over the network has lots of possibilities, especially when you're now able to remotely troubleshoot your voters. As example, if you want to status the state of, for instance, site number 3, that would be site number 3 of a voter that's equipped with the older CPM-1 module, we must use a terminal emulator and instate the command stat3, which means I want to status site number 3. The result would be a cryptic 3-byte word. The first byte would be the site number, which is number 3. And you can see how tedious this can be if you're trying to troubleshoot your voter at the voter site. Next is the status byte, and that would be the first status byte, which provides information such as whether the site is unsquelched, voted, or even faulted. And there are approximately 38 different status bytes that are listed in the SNV-12 installation manual. So as you can see, the use of status bytes can be pretty overwhelming, especially you're at a voter site without the manual. The last status byte is the audio quality byte, where the higher value represents the receive audio quality as being high in quality or exhibiting low noise. This value of 1 means that the site is probably very noisy and will probably not be voted. On the other hand, one can log into the CPM-3 control processor module using a web browser, and we can immediately view the status of all site voter modules within the chassis all at the same time. So this is a close-up view of the SVM2 site voter module, and there is a mode selector switch, and from the normal operating position in the center, one can manually force vote the receiver by flipping the switch to the select position, the upper position, and then flip the switch down, and you could make that site ineligible to be voted. In other words, that site will be disabled. The 3-site SVM3 module has similar switches. And as you can see in the CPM-3 web browser console at the right, there are buttons that allow these functions to be instated from anywhere on the network. And later we'll see how we can use these buttons to help us troubleshoot the voter remotely. From the CPM-3 web console, you can even guide or steer the transmit audio to a specific site. This is manual steering, manual transmit steering. Again, we can do this from anywhere on the network. And conversely, if we use a terminal emulator with the CPM1 and use the command select 1 on, this will place site number 1 into a forced voted or a select state. And you can see that the flashing LED on the front of the site voter module, the voted LED, indicates that that site is being force selected. And we can then revert the site back to a normal state by selecting, using the command select 1 off. So again, users can use the virtual buttons in the browser panel to force vote, force disable, even transmit steer individual sites, or even all modules in the chassis at the same time. Again, this is very useful capability for remote troubleshooting. And instead of removing the module from the chassis to visualize the dip switches and rotary switch settings of each site voter module, the web console displays all switch settings and references those switch settings with readable text. So no need to cross-reference those cryptic status bytes with the SNV-12 manual. The information page is specific to the CPM-3 module, and for the most part, those settings are typically global and affect all modules equally. And that's a good rule of thumb for those of us that are troubleshooting or setting up the voter. And global settings features are handled by the control processor module. For instance, the voting mode, either FM or AM, is a global function that must affect all modules equally. So the setting, that setting is provisioned from the control processor module as an example. The firmware versions of the modules are also displayed, and most importantly, the firmware version of the CPM module itself is displayed. And the latest CPM-3 firmware series that supports IP backhaul version is the 2.x version. And all 1.x firmware builds will not support IP backhaul. And in fact, voters that do not contain IP backhaul related modules, such as the CPM-3, can still use the 2.x version of the firmware. So if you like, you can always update to the 2.x firmware version, and your voters will still continue to support your SVM2 and analog backhaul links without any problems. And since we're on the subject of firmware, the CPM module contains all the firmware used by the subordinate modules, such as the CIM module, the SVM modules, and even the CPM module itself. And every time the chassis is turned on or rebooted, the CPM module queries each of the modules for their latest firmware version. And if the firmware mismatch is detected, firmware will then be delivered to those specific modules over the internal data bus. And modules will update in a serial fashion and may take several minutes to complete the fully populated chassis. Incidentally, if you add a new module to a live operational chassis, the CPM will detect the presence of the new module and then query that module for its firmware version. And if there is a mismatch, firmware will be installed just to that module. Incidentally, the CPM-3 also has a forced update function if you need to reinstall firmware into the subordinate modules for troubleshooting purposes. So, unlike the CPM-1, firmware is delivered to the CPM-3 via a network-connected computer. And so, as you know, you can download the latest firmware and tools to load the firmware from the download link on our website at jpsinterop.com. Obviously, those downloads are at no cost. And by the way, we no longer support the CPM-1 EEPROM chips, and our stock is fairly well depleted. And I believe the latest CPM-1 firmware version is 4.16. You can see the version of the EEPROM chip on a sticker on the top of the chip itself. So the system module configuration page is probably one of the big changes associated to the 2.x firmware version of the CPM-3 Control Processor Module. And this is an integral part of the IP backhaul solution. And depending upon the site voter module that populates a specific slot in your chassis, you can assign that slot to either support an SVM2 or an SVM3 site voter module, and the site numbers will automatically be sequenced and assigned. A significant change is the addition of the path delay value entry, and this is the same as the adjustment of the receive audio delay of the SVM2 module, and specifically the SW1 rotary switch located on the SVM2 circuit board. And with the version 2 firmware, the receive audio delay rotary switch is no longer functional. And remember, we use receive audio delay to adjust the arrival time of the receive audio at the voter. And so the path delay value that you enter into the console is equivalent to the receive audio delay that you instate in the SW1 rotary switch on the circuit board. And so the receive audio arrival must occur simultaneously. This can be tested by force voting multiple receive sites at the same time and then listening for the audio echo or reverb. And remember, you can force vote sites from the mode selector switch in the front of the module, or conversely from the web browser console as we saw earlier. And we'll see this again a little bit later. You can also assign the SVM3 digital site voter module. And since that module can support 3 receiver sites, you can see that's been assigned with 3 numerical sequential site numbers. And you might also notice that there are no provisions to enter the path delay, also known as a receive audio delay, for this SVM3 site voter module. So if you attended our past IP backhaul webcast, you'll recall that the solution will automatically adjust the receive audio delay of the SVM3 site voter module to compensate for network jitters. So path delay of the SVM3 is controlled automatically by the control processor module. And alternatively, you can also physically populate the chassis ahead of time with your SVM2 and SVM3 modules, and then click on the Adopt Currently Installed Modules button at the bottom of the user interface. The modules will then be recognized and the sites will be automatically sequenced and populated. At the bottom of the CPM-3 information page is a chassis identifier function, and when enabled, LEDs on the CPM-3 module will continuously flash for up to 2 minutes, and this can be handy if you have a huge wall of voters. And incidentally, if you have a multi-shelf chassis, meaning 2 or 3 chassis connected together with a JPS expansion cable kit, you only need to log into the master chassis if you're interested in using the web browser features of the CPM-3. And the CPM-3 is also capable of counting unsquelched, voted, and fault events over different periods of time. Logging the event counts can be a great way to determine if there's an issue with a specific site. For instance, you may notice that the site shows a high unsquelched count and a very low voting count. This might be attributed to, for instance, the equalization issue with adjacent receiver sites exhibiting high-end roll-off in the region of spectral noise, where we assess the quality of audio. This means that the site is being considered for selection, but adjacent sites, because of the high-end roll-off, are inadvertently being considered as audibly cleaner. Another example, if you have a high fault count, and this can be attributed to either the momentary loss of the pilot tone or maybe the effects of maybe EMI misrepresenting the idle tone. And this means that the pilot tone is going away, but there is no voice audio present. And if the site exhibits a low unsquelched count, there may be an issue with the receiver's antenna, the directivity, or cabling, which means that the effective coverage of that site might have poor gain. So statistics counts can really be an important tool when troubleshooting. Another handy troubleshooting tool in the CPM-3 is the event logging tool. As you can see, we can log the same statistics that we've seen in the statistics count panel. This also includes the transmit events, but because of the real-time clock, you can also timestamp those events, and those events can be optionally sent to the event history table below, and can also be delivered to a terminal emulator via the RS-232 serial interface at the back of the Voter chassis. You can copy the resulting CSV file from the terminal emulator and paste it into a spreadsheet for review purposes. And one quick note on the real-time clock, you'll need to manually set the clock. Otherwise, the clock resets to 0 after each power or reboot cycle of the chassis. You can also install a CR2032 lithium battery to lock the clock over power or reboot cycles. And note, the CPM-3s are not shipped with batteries. And finally, I feel one of the best little-known features of the CPM-3 Control Processor Module is the ability to use PCNXU applet to listen to the voted and or the transmit audio of the voter chassis. And this is a capability that is not in the CPM-1. And once again, you can download PCNXU from our website at no charge. And because PCNXU implements the JPS ROIP protocol, and because PCNXU is a ROIP client, we can associate PCNXU to the CPM-3, which is a ROIP server. And by default, the ROIP link will use the 13 kilobit GSM vocoder. You can also create multiple PCNXU profiles that you can associate to all your SNV-12 voters in your system. So from the CPM-3 network panel, you can see the ROIP port value and also the selection to whether you want to listen to the voted audio and or the transmitted audio, which can also be the console transmit audio. And not only can you simply listen to the normal voter activity or traffic from the remote location, but you can use one of the most powerful troubleshooting tools by force voting a suspect site, listen to the audio, and even remotely disable that site if need be. And this allows you to isolate the questionable site and allow the voter to continue voting as normal. And you can even address the problem at a later time. And really, the ability to listen to the voter audio remotely is probably one of the best features of the CPM-3 module. I know of a few customers that have CPM-3 modules in their current voters, but are completely unaware of the monitoring and control tools of the module. So those tools can really save valuable time and cut down those unnecessary trips to the voter or the receiver sites during troubleshooting activities. And you can even conduct much of those troubleshooting activities remotely. So really take advantage of those tools if you do currently have CPM-3 modules in your voters. And if you do have voters with the older CPM-1 control processor modules, upgrading your voters with the newer CPM-3 modules is as simple as taking the switch settings and jumper settings from the CPM-1 and transferring those settings to the CPM-3 module. And this will also help prepare you for those voters to support IP backhaul in the future. And so I'd like to thank all of you for joining our webcast today. And if you need more information regarding the CPM-3 Control Processor Module or the SNV-12 Voter or even IP backhaul solution, you can always call us directly or visit our website at jpsinterop.com. And Carol, you have something you want to close with?
We appreciate everyone joining us today. We look forward to visiting with you again next Wednesday. Thank you so much. Have a good day.